Okay, so we're gonna do an experiment, which is that if you generate rectangle images, such as these, and then you train a convolutional neural net, such as this one, to distinguish between rectangular images and noise, and then you do the thing where you backpropagate to pixels. You backpropagate the pixels to produce arrays of pixels that the classifier network interprets as rectangles, and then you get like images that look like this, and like this. These don't really look like rectangles to me, a human, and so what we're gonna do is oh yeah, that's all garbage. Don't pay attention to any of this. Okay, so anyway, so what we're gonna do is we're gonna modify the like training procedure for the neural net, where we're going to, it'll almost kind of be like a GAN, I guess, but it'll be like so we're gonna train. So the training procedure for the neural net is like distinguishing like noise from rectangles, right? Like we generate a noise loss, and we're using I guess normally distributed noise. Yeah, there's also like some issues with norms, which I'm going to completely ignore. But anyway, the loss generally is like you have your neural net, and then you have you generate noise images, and you run them through the neural net, and it's supposed to output. It's supposed to activate one of the outputs. Like the output of the neural net is 2 units for each class, noise versus rectangle. And then you have the rectangle loss, and so you just generate some rectangles, and then you do the same thing. And so we're going to modify this to, I think, something like every epoch, like maybe every 4 epochs, perhaps. We're going to do an extra thing where we're going to generate, like we're going to do the backprop to pixels to produce fake rectangles, and then we're going to also train the neural net to distinguish the fake rectangles as, like we want those to be classified as noise as well. And so we're just going to see what that does. So, I don't know if I just want to modify these. I think I'm gonna have to do some copy pasting, unfortunately, but you know. Okay, so anyway, this is training on fake rectangles. I need to come up with like another word for when you backpropagate to pixels, but I just call them fake. Okay, so that is the okay, so this is the neural net. So this is the training codes, and then we need the backprop to pixel codes. Like, is code a count noun or a mass noun, you know? Okay, so this is backpropping to pixels. I'm not quite sure how I'm going to implement this, because I think like this needs to be a function. Yeah. So we're going to make this a function, or like a, well, yeah, like a function. So, generate fake rectangles. I guess, like, does it need to take the neural net as an argument? So this will generate, it looks like 100 fake rectangle images. And I guess everything is cool. So then, so we just return the pixels when we're done training. So then up here, I think we need to say, not quite sure how to do this, because, I mean, the thing that might happen, which probably won't, but the thing that might happen is that at some point, the fake rectangles will actually be real rectangles. I mean, that's almost definitely not going to happen, but, like, that's what we're going for. So, fake rectangle loss. Do we need to do this, like, every epoch? I mean, it's kind of like, why not? You know? Oh, also I messed that up. This needs to not separate that. Okay, so fake rectangle loss. I guess we can just do it every epoch. So we just say fake rectangles generate. Well, let's see. Does that need to be in the gradient tape? Like, I don't know if that's going to affect. I don't know if that's going to affect the. Yeah, maybe not do it inside. I feel like that might affect stuff. So we'll do it here. Generate fake rectangles, passing in, I guess, the neural net. And then, yeah, you just add this loss. So we say loss plus equals norm between the fake rectangles, which we just generated, fake rectangles, and subtracting off. Yeah, so those are supposed to be activating the 0 output, which stands for fake. Okay, that all looks good, I guess. So we'll just see what that does. So I need to, like, run this, and I need to move that up, actually. Okay, and we're just gonna run this and see what happens. Oh, I'm only using 9. Okay, I misread that. Yeah, so this should be 9. Oh, come on. As tape 9 by 2 versus 100 by 2. Does this need to say 9? Yeah. Okay. The loss is, uh-oh, it broke. So then we'll display the fake rectangles also. Maybe? Yeah. So yeah, let's like just display the fake rectangles at every epoch as well. Epoch? Epic? Don't know how you say it. So this needs to be 3 by 3. And that needs to have a 3. And I don't care about that. Alright. Oh no. Oh, it's fake rectangles. Okay. Cool. I can't tell what's happening. Oh no, it broke. So it tends to break. I don't know why. Let's see, 16, and then zoom out. Okay, so what happened? Whoa, whoa, whoa. Okay, so I should print the epic epoch. Okay, so this is a random neural net, and like these all activate the rectangle output. I mean, it hasn't been trained at all, so they shouldn't resemble rectangles. Okay, now like a thing that's weird is that these all are very similar looking. And also, none of these look like rectangles. Like, maybe we're doing too many epics here. Like, what if we say, like, while the loss, because I guess you want to stop it once the loss is like a particular magnitude, but we'll just turn down the number of epochs for the fake pixels and run it again. Like the error gets stuck at like 4.2 for the classification error. Like if we train it using the regular loss, like up here, the error starts at 4.2 and it goes down to like very, very small. So maybe if I make more real rectangles, because every epic it has 18 like fake examples. So if I make this 18 for like the real rectangle loss, right? That's a pretty good idea. Okay. Let's see what that does. Like, yeah, like the classification error like is not going down. Like it gets stuck at 6. Okay, so just to be clear, if we take out the fake loss, take this guy out, and then the classification error should go down much more. Yeah. 3.5, 3, 2.6, 2, 1.8. Under 1. Well, kind of. So when we add in the fake loss, we're possibly like hitting... What if we make the neural net like much larger? Right? Absolutely. Also, what if I don't know if I should use ReLUs. I mean, well, okay, well, first of all, let's just make it larger. So, like, 32, I don't know, 32 by 32, right? That's pretty big. And, so then include the fake rectangle loss. So we're at 6 on the error, classification error, and it got stuck, and then it blew up. Like, make the training slower. Then I'm gonna try 10H. Like, if ReLU doesn't work, try 10H, yeah. Yeah, like, it doesn't go below 6. Why? Okay, so we're gonna try 10H. And, should I use, like, another filter? Like, another layer? Just don't know. 10H, see what this does. Whoa, that's weird. Oh, that doesn't look good at all. It's also stuck at 6. Why are they all stuck at 6? This is weird. Okay, do it without the fake loss. Yeah, like the loss goes down like 3, 2. Well, kind of bounces around, I guess. So... Maybe do that? 5, 4. Okay, now it's like we're not even training like on the normal training. Okay, turn these back down to 9. Or just make this 18, or I don't know, make this 9. And 16, 8. Okay, so now, I mean, we're completely failing just on the normal training. Like, without even using the fake rectangles. And it was working before, so... Do we need ReLUs? Okay, so before we were doing 32, 16, 8, and they were all ReLUs. So we'll go back to that. 32, 16, 8, and they all have to be ReLUs. Like it's kind of going down more, 1.5. Okay, and then, so if I bring back the fake loss, turn this down to 9, or, no, turn this back up to 18. If we could get the error down to like 2. Hey, there it is. The error is around 2. Oh, there it is. Look at that. That's a very low error. 0.17. Okay, so... Okay, now the weird thing is that... oh, did I not... Oh, that's why. I was using the same rectangles the entire time. Well, it's doing something. Kind of. Huh. Okay, so... we couldn't get the error below 5. But, like... if I do run it on... like... real rectangles and noise, what does that look like? So... okay, so on the noise, it's supposed to be the first unit is maximally activated, which seems to be true. These are all basically 1.0. But then on the real rectangles, it doesn't know what to do. Like, it's like 50-50. Huh. And what about fake rectangles? Also, don't do this. On that fake rectangles. Oh, you have to like, oh, you have to print it. Right. Also, I messed that up. I need to get the noise loss again. Where'd it go? Because this was the actual noise loss. Okay, so in noise, like, we're perfect. It's the 0 output. 1.0. And on real rectangles, we're completely uncertain, and on fake rectangles, we're also completely uncertain. It's like 50-50 on both. Huh. Well, that's kind of interesting, I guess, right? So, like, we learned that if you do this crazy training procedure, you get a neural net that can classify noise very accurately, but it can no longer distinguish, like, fake rectangles from noise, nor real rectangles from noise. So, yeah, come up with an interpretation for that, right? I'll do that in the next video.